I'd like to introduce our next guest. Please welcome Paige. Hi, Paige. How are you?
Hi, how are you going? Good, thank you. How are you?
Great to see you. Thank you so much for joining us here on the Global Biodiversity Festival 2021. It's so nice to see representation from Australia.
Absolutely. Thank you for having me.
All right, the floor is yours. Take it away.
All right, I'll share my screen. Alrighty, can you see that one? I'm gonna go ahead. My name is Paige. I'm from the University of Technology in Sydney. I'm with the Future Reefs and Ocean Microbes Lab, and today I'm going to be talking to you about coral propagation and outplanting, and what does it mean for the microbiome of corals on the Great Barrier Reef. First, I would just like to acknowledge the traditional custodians of the land on which I am broadcasting from today, along with the traditional custodians of the land and sea country on which I conduct my research. I pay my respects to their elders past, present and emerging. The Great Barrier Reef is one of the natural wonders of the world. It is made up of microscopic organisms, yet can be seen from space, and is a UNESCO World Heritage listed area with outstanding universal value. The Great Barrier Reef is one of the most complex natural systems on Earth and supports some of the most biodiverse ecosystems on the planet. It's hard to sum up the biodiversity it holds. From the more than 400 coral species, more than 1,500 species of tropical fish, over 200 species of marine birds, and more than 25 species of marine reptiles, alongside mollusks, sponges, anemones, and microorganisms too small to be seen with the naked eye. Not to mention the vast seagrass meadows and mangrove forests protected by the reef. However, coral cover across the Great Barrier Reef is declining at rates never seen before. And this is a result of a range of stresses, such as outbreaks of crown-of-thorn starfishes, which decimate coral reefs, eating coral tissue at a rate of 10 meters squared per year, flood plumes and runoff from agriculture and coastal development, and overfishing, which depletes stocks and disrupts the balance of the ecosystem, just to name a few. These pressures are then compounded by climate change, driving ocean acidification and rising ocean temperatures, which often leads to widespread coral bleaching and consequent coral mortality. Consecutive thermal stress events in 2016, 2017, and 2020 caused mass coral bleaching in the northern two-thirds of the Great Barrier Reef, resulting in very high levels of coral mortality and subsequent altered species community composition of coral. For example, 90 coral species, which dominate many reefs, declined by more than 75% at severely bleached sites, leading to the significant loss of 3D structure and major losses of biodiversity. While coral reefs have an innate capacity to naturally recover, this takes time, sometimes anywhere between 10 to 15 years. But the frequency, intensity, and severity of mass coral bleaching and extreme weather events is increasing. For example, there have been 3 mass bleaching events on the Great Barrier Reef in the past 5 years. As such, the time and capacity for natural reef recovery between catastrophic events is diminishing. To add to that, coral larvae and post-settlement survival are often compromised by these chronic and repeated disturbance events. Now, this is all very concerning, and it's clear interventions are required. So what can be done to help? Well, first, we need to understand what coral is. The hard coral structures we see on a reef are the skeletons of corals that house thousands of coral animals, referred to as polyps. Coral polyps are tiny, soft-bodied organisms related to jellyfish and sea anemones. And just like jellyfish, corals have tentacles, which with stinging cells used to subdue their prey. As you can see, corals are colonial organisms, that all the polyps are there working together and depending on one another for survival. And there's something corals and humans have in common. Similarly to humans, corals have associated bacterial communities, referred to as a microbiome. And as with humans, the coral microbiome is known to be important for overall coral health. There are many bacteria within the microbiome that carry out important functions for corals, such as acquiring and transporting nutrients, protecting corals from diseases and pathogens, and sometimes tolerance to environmental stress. And it's similar to how humans might consume probiotic products such as yogurt to increase good bacteria. It is important for corals to maintain a good microbiome in order to be healthy and resilient. Aside from this, corals have a few methods of reproduction, falling under categories of sexual and asexual reproduction that can be utilized to aid reef restoration. So, what are we doing to help? Alongside driving policy changes to address action on climate change, enforcement of marine park zoning, and increased monitoring, scientists, stakeholders, government, and traditional owners are working to protect reefs through a series of active management approaches to buy time for coral reefs during the time required for action on climate change to take effect. Active management approaches generally all involve a direct human intervention and includes methods such as substrate enhancement or propagation and outplanting. With substrate enhancement, the overarching aim is to increase the available substrate or provide more suitable substrate for corals to settle on. For example, we're using artificial structures in artificial reefs and rubble stabilization techniques. And substrate enhancement also includes mineral accretion, using electricity to encourage calcium and magnesium to precipitate on artificial structures and mimic natural reef substrate to again increase recruitment of corals. With propagation and outplanting, the overall goal is to directly increase coral biomass and coral cover at degraded or high-value reef sites. And propagation borrows techniques from silviculture. It's very similar to taking clippings from a plant to grow new ones. So propagation can either include an intermediate nursery phase prior to outplanting, or in the case of direct transplantation, fragments are located and secured immediately back onto the reef. Propagation and outplanting with an intermediate nursery phase utilizes a natural method of coral reproduction mentioned previously, which is asexual fragmentation. And this method is increasingly being used to manage coral reef declines globally, owing to the low tech and low cost of application. And the first coral nurseries on the Great Barrier Reef were established in 2018 by the Coral Nurture Program and have been really successful. Fragmentation of a coral colony and an intermediate phase within a coral nursery can lead to rapid growth of coral fragments before outplanting to bare areas of the reef. You can see here the rapid increase of coral biomass on this nursery frame within just 1.5 years. And the frames become little mini reef environments, providing habitat structure for lots of different fishes. We can see that also after outplanting, coral fragments continue to show rapid growth, as seen here in these photos, which are only 2 months apart. There's been lots of growth happening, and you can't even see the clip used to secure the fragments. So what about the coral microbiome that I mentioned? Well, Despite the recognized importance of the coral microbiome to coral health, the variable survival of outplanted and propagated corals, and knowledge that different coral species show unique microbiome dynamics in contexts outside of reef restoration, it is still not known how the coral microbiome is impacted throughout coral propagation and outplanting, and this represents a significant knowledge gap. My PhD research is aiming to address this knowledge gap by tracking bacterial communities of corals throughout different phases of propagation and outplanting. We aim to contribute knowledge that will allow restoration practitioners to optimize their procedures and propagate corals with healthy microbiomes, most conducive to growth and survival. And this involves tracking coral fragments from known source colonies over time throughout nursery phases and on to after outplanting. As you can see, it involves lots of ferrying fragments around the reef, and you usually have your hands full of many items for sampling and transport. So far, I've found that different corals show unique microbiome responses to coral propagation and outplanting. This is important because it might mean that species-specific considerations are required in future outplanting efforts. Unfortunately, I can't share any more specifics because this research is so far unpublished. So you have to keep an eye out for when it is in the press. But yeah, I hope you have enjoyed the brief view into the coral microbiome with me. And I would just like to thank all of my supervisors, lab reef mates, and the Coral Nurture Program for their help, because none of this would be possible without them. So thank you so much for your time. I hope you enjoy the rest of the Global Biodiversity Festival. You can find me on Twitter, Instagram, and via email if you have any questions. And I would love to take some questions now if there are any.
Thank you so much, Paige. That was really, really insightful.
Thank you.
Lovely. Okay, well, I have a question actually. How badly damaged has the Great Barrier Reef become over the years in terms, of a percentage?
So there are figures showing that there's overall approximately 50% of coral covers been lost since the 80s. Recently, the bleaching in 2020 was patchy, and we were saved by quite a bit of cloud cover coming through. But yeah, there's a lot to be done to help recovery between hopefully the next bleaching event that won't be too soon. But yeah, you never can tell.
Yes, I mean, we've been facing the same problems with our corals this part of the world in Malaysia too. A lot of coral bleaching. But sadly, I mean, we do have as well people who are doing coral planting and trying to revive the reefs, but it does take some time.
Absolutely, yeah. And without removal of the stress that they're under, we are only buying time for them, unfortunately.
Yes, maybe you can tell us and the listeners a little bit more about what goes on in this planting process. Is it some people think it's as easy as plucking off a piece of coral, sticking it to a wire, and just leaving it in the ocean, and in 2 years it's a whole reef onto its own?
So it is fairly simple. There's two main techniques that are used. Obviously, mine is looking at the techniques with the intermediate nursery. One of the main ones that a lot of tourism operators are helping with on the Great Barrier Reef is where they find fragments of what we call opportunity. So where they might have been broken off by natural processes such as storms or hungry fish that have come along. And then depending on the size, they might be broken up into smaller pieces. And we use a spring clip that has been made by the Coral Nurture Program. It's hammered into the substrate. We clean it off a little bit, and then you wedge the fragment underneath. And it is pretty much as easy as that. You come back and hope by even a couple of months, they can have overgrown the clip. So yeah, they do show some rapid growth.
Excellent. Thank you so much. We have a question here. Fallon would like to know, what type of school did you go to? And how did you get to where you are today?
Oh, good question. I went to a regular school. I think I actually went to school in England. And then I went to university in England as well and did a exchange over to Australia. That's where I really found my interest for coral microbiology. And yeah, I pretty much pestered people to let me volunteer in their labs on topics that I was really interested in until I could pester someone to let me do a PhD with them. And yeah, I've been lucky enough to be doing research on my dream project.
Well, there you go, Fallon. Better start pestering people now.
Absolutely.
We have another question here from Danielle from Mauritius. She is working towards educating the youth about coral reef protection and conservation and would love to use your amazing infographics. Would it be possible to get access to it, or can she contact you privately to talk about it?
Yes, absolutely. Send me an email or a message on social media. I also do some infographics for the International Coral Reef Society. So I would love to help out with your project. Sounds great.
Great. Maybe you can tell me your Instagram handle that she can reach out to.
Yeah, my Instagram is P for Paige, and then it's just Strud, P Strud.
Perfect. So I'm just going to put it up here. Danielle, there you go. You can get in touch with Paige on her Instagram, which is pstrud, and check out all the wonderful work that Paige is doing as well. We have another question, also from Danielle. I have heard about supercorals. Do they differ from region to region? Would love to know, because in Mauritius, we could have supercorals according to our location.
Wow. Yes. So actually, one of my supervisors, Dr. Emma Camp, is researching supercorals. She did a speech on it for Global BioFest last year. I am not an expert in that field, but I understand that they are found in extreme environments such as the mangroves up on the Great Barrier Reef. So it would be interesting to see how the ecosystems over in Mauritius are different if you have any corals existing in already stressful or usually stressful conditions. And then, yeah, that'd be super interesting to look into.
Yes, speaking of stressful situations, we have another question from Kelly, who's doing similar work in Singapore. The corals in their coral nursery are bleaching, despite them ensuring all parameters to be ideal. So the question is, they were wondering if it could be a microbiome actually. How do they know if the corals are suffering from stress due to unsuitable or insufficient microbiomes?
I would say that do they have potentially corals on the reef that are experiencing similar conditions? There's a recent paper that's come out highlighting that there may be diseases of microbial origin that are overlooked throughout the nursery and propagation process. So potentially you could look into methods of characterizing the conditions that the corals are under and the symptoms that they are showing, because it might not just be bleaching, there may be other signs of bacterial disease, and they could look into that side of things. It's very hard without having some context or source colonies on the reef to compare them to know whether it's really something in the nursery or if it's also something that the reef is experiencing.
Thank you so much. I was just going back over the notes from your presentation, and you were mentioning that, the first coral nurseries of the Great Barrier Reef first started in 2018. Is that correct?
Yes.
Okay. So, what's the status now of these coral reef nurseries? Have they successfully recovered? And how much has this led to the recovery of the Great Barrier Reef?
So luckily we haven't experienced much bleaching on our nurseries, and throughout the coral nurture program we've outplanted almost 20,000 corals so far. So there's been some really interesting research coming out tracking growth and survival, return on effort, depending on, I guess obviously cost effectiveness is a very important aspect of these things. So I think those figures are pretty impressive for just a few years of 20,000 corals planted back onto the reef.
Yeah, it sounds fantastic. And I think, as with everything else in conservation, every little bit helps.
Absolutely.
Is there any way people can, if people want to help with the coral nurseries in the Great Barrier Reef, is there any organization that they can reach out to?
So there's lots of different foundations now that are working on these similar projects. I think the main thing is that knowledge is power. So it's just to start having conversations with people and sharing what's really going on. Get in touch on social media, share these things around so more people can find out about it, which helps with the funding down the stream to put all of these things into practice.
Fantastic. Thank you so much for your time, Paige. It's been a pleasure. Stay safe.
Thank you. Take care. Thank you. Good luck with everything else.